Hey guys, it's Mike RXR, and these are my GRS 8-inch antique railroad highway crossing flashers. And I'm going to show you how I got these flashers to work. Now if you want to get your own flashers to work, easiest choice might be to go on to one of those websites like Lights to Go and buy one of their very good flashers that's ready to go. You follow the directions, you wire it up, it's solid state, doesn't make any noise, it's adjustable, they work great. Other option would be to get one of the old antique railroad relays and power it up. I tried that first, and that works great too. It's authentic, it's kinda loud. And then you got my way, where I used all my own parts from the automotive store. I'll show you how I got that set up. Now we just assume you got a 12-volt power supply of some kind, and I'm just using a little Radio Shack 1, 13.8 volts, 3 amps. Basically very similar to what you'd have in a cigarette lighter on a car charger. And I bought two components from the auto parts store. A turn signal flasher. I first bought the standard thermal one, which runs about $2, and had some problems, so I had to buy a solid state one. So this is an all electronic flasher. They run about $7 or $8, and this will work whether you have the load of a light bulb on it or not, which is convenient. So I got that. That was made by Bussman. And then I also got a little relay, standard 5-prong automotive relay, used in a lot of different applications with automotive lighting and ignition systems. It's a very simple relay. It may look complicated at first, but you'll find it either in the help section of the store or the behind the parts desk. Now if you buy it from the help section, it might run you $15, but if you go to the parts desk, get it for only $6. So you want to try to get the cheap generic one. Now on here you're going to find a set of pins. Very simple. I did a little drawing there. You got 86 and 85, which are across from each other, and basically that's just your positive and your negative, which are going to power the relay. And then 30 is where you bring an alternate power source in, or the same power source, and basically when the relay is engaged, it'll go from its normal resting position, 87A, to 87, back and forth. 87A, you could call it 87 always, because when there's no power to the relay, that's where it's going to be. So it's just going to go back and forth between the two. How the relay works is pretty simple. I did another drawing of that. Here's a drawing of how the relay works. As you can see, 86 and 85, you got your positive and negative, and there's a coil there, and that coil pulls down this switch here. So when it's energized, it pulls it down from 87A to 87. I drew little pictures of light bulbs there. So you got power coming in here. Every time the relay is energized, it's going to go down here. This light bulb's going to go off. This light bulb's going to go on. So it's fairly simple how that works. I'll show you how it works on the whole diagram. You got your power supply here from the battery. You run that up to an electronic flasher. But before the flasher, you splice off and you come up here to 30. So 30's got constant power, but 85 has flashing power. And before you get to 85, you want to run it to one light. So one of your crossing lamps is controlled by the flasher, and at the same time the relay is being activated. Your other one's controlled by 87A. So it's a little bit backwards. The 87A in this case does not always have power. It's the resting position for the switch. It's kind of confusing, but I drew it out there to make it pretty simple. So when we activate the power supply, flasher starts up, relay engages, and back and forth. It's a little faster than your normal railroad crossing lights, but it works pretty good. And I took out the old signal lamps and put in these 1156 automotive bulbs. They fit in the same socket perfectly, do just as good. So that's pretty much it. The only thing I'm forgetting to mention is it's always a good idea to put a fuse in between your power supply and your flasher. There's one built into my power supply, so I'm not too worried about it. It takes a minute for these things to energize and activate. I'll show you. Power on. And there you have it. Pretty simple. It's not too loud, it clicks a little bit. But it's pretty fun doing it yourself. And the components are easy to replace.